Hello everyone. In previous class, we discussed about wave shaping circuit and transistor as a switch. पिछले वाले लेक्चर्स में हमने ये भी देखा था कि ट्रांजिस्टर को हम एज अ एम्पलीफायर की तरह भी यूज कर सकते हैं और एज अ स्विच की तरह भी हम इसको यूज कर सकते हैं. Now, in this lecture, we will study about what is multivibrator. After this, we will move on the classification of multivibrator, like astable multivibrator, monostable multivibrator and bistable multivibrators. तो ये जो हैं ये तीन टाइप्स के multivibrators हैं, इनको हमें डीपली स्टडी करना है. So this is third one, bistable multivibrators, and finally the references of this presentation. So in this lecture we cover all these topics one by one. So let's start with topic 1, introduction of multivibrator circuits. So first question occur in our mind, what is multivibrators? So the definition of multivibrator is an electronic device that produces a non-sinusoidal waveform as its output is known as multivibrator. The generated non-sinusoidal waveform are basically a square wave, rectangular wave or triangular wave and sawtooth wave or ramp wave etc. तो मल्टीवाइब्रेटर सर्किट एक ऐसा सर्किट है जो कि प्रोड्यूस करते हैं नॉन साइनसोइडल वेवफॉर्म, जो कि स्क्वायर फॉर्म में हो सकता है, रेक्टेंगुलर फॉर्म में हो सकता है, ट्रायंगुलर में हो सकता है और सॉटूथ वेवफॉर्म में भी हो सकता है. तो मल्टीवाइब्रेटर का काम होता है नॉन साइनसोइडल आउटपुट देना. It is a two-stage RC couple amplifiers that operate in two modes. The modes are basically termed as states of the multivibrator. Basics of multivibrator. The multivibrator is a switching circuit and its basic configuration is shown in a figure. So this is the basic diagram for multivibrator circuit. Multivibrator circuit consists two amplifier A1 and A2. Connected in this way, the amplifier 1 output acts as an input of amplifier A2. मतलब हम दोनों एम्पलीफायर को इस तरीके से कनेक्ट करेंगे कि जो A1 का आउटपुट है वो A2 की इनपुट की तरह काम करेगा. एंड two coupling circuit or coupling network also connected in this circuitry. One coupling network connected directly to the amplifier A1 and A2, and second coupling network is connected to the as a feedback path. Here two amplifiers are employed in which the output from the first stage acts as an input to the second stage. The output of second stage is then through a feedback path is provided to the input of the first stage. Here the operation of the circuit is controlled by two conditions, on and off of the circuit. So this is called the switching device. It performs oscillations between high and low state, that is 0 and 1, thereby generating a continuous output. A multivibrator has the ability to store binary numbers, count pulse and at the same time synchronization between the arithmetic operation is also maintained by the multivibrator in a digital system. Next topic is the types of multivibrators. The various types of coupling network are basically categorized by the types of coupling network that is employed in the circuit of the multivibrators, and these are multivibrator are classified into three categories. First is a astable multivibrator, second is a monostable multivibrator, and third one is a bistable multivibrator. So the first one is astable multivibrators. So definition of astable multivibrators. An astable multivibrator is a type of multivibrators that does not require a triggering pulse, thus sometimes known as free running multivibrator. It necessarily provides square wave as its output. The figure below show the configurations of the astable multivibrator. So this is the diagram of astable multivibrator. क्या होता है इसमें ट्रिगरिंग पल्स जो होती है वो नहीं होती है, ट्रिगरिंग पल्स जो होती है उसमें एब्सेंट होती है, और ये मल्टीवाइब्रेटर हमें आउटपुट स्क्वायर वेव के फॉर्म में प्रोवाइड कराता है. Astable multivibrator is called so because both the states present here are unstable, that is the quasi state. This means outputs swing between 0 and 1, and neither 0 nor 1 is the stable state. क्योंकि इसमें जो दोनों स्टेट हैं 0 और 1 मीन्स ऑन और ऑफ की वो स्विंग होती रहती हैं, इसलिए हम इसको अनस्टेबल बोलते हैं, मतलब ये स्टेबल कंडीशन में नहीं आ पाता है. सो दिस इज नोन एज द अनस्टेबल मल्टीवाइब्रेटर. Here the successive transitions is made from one quasi state to the other after some pre-decided time intervals. Next is the circuit and operation of astable multivibrator. In this section, we will discuss the operation of an astable multivibrator by collector couplings and by using a complementary pair of transistors. Let us first understand collector coupled astable multivibrator. चलिए पहले हम देखते हैं collector coupled astable multivibrator क्या होता है. So this is the diagram of collector coupled astable multivibrator circuit. In this circuit, two transistors are used, Q1 and Q2, and resistor and capacitor combinations are used. So this is the circuit diagram for collector coupled astable multivibrator. The two transistors Q1 and Q2 are employed here, which are back-to-back connected. It is to be noted here that the two transistors cannot be exactly identical. This means on applying the power VCC, both transistors start conducting. But due to the variation in operating characteristics, one conducts more than other. Let us assume that Q1 conduct more than Q2. क्योंकि दोनों के दोनों हमारे जो ट्रांजिस्टर हैं वो आइडेंटिकल नहीं हैं, तो हम मान के चल रहे हैं कि पहला जो हमने सपोज किया कि Q1 जो है वो ज़्यादा देर तक कंडक्ट कर रहा है और Q2 जो है वो कम कंडक्ट कर रहा है. So we consider the conduction of Q2 as almost negligible. Hence, considering only Q1 is conducting. When Q1 starts conducting, it starts to move towards saturation region. This causes the collector potential Vc1 at Q1 to become minimum. As we can see in the figure, that the collector of Q1 is connected to the base of the Q2. So, the low voltage at the collector of Q1 is fed to the base of Q2. Due to applied low potential, transistor Q2 reaches the cut-off region. चूंकि हम ऑन और ऑफ की बात कर रहे हैं, मैंने आपको पहले भी समझाया कि कट ऑफ रीजन का मतलब होता है कि ट्रांजिस्टर जो है हमारा स्विच्ड ऑफ कंडीशन में एक्ट करेगा, और ऑन अगर करना है तो हमें सैचुरेशन रीजन में जाना पड़ेगा, या जब हमारा ट्रांजिस्टर सैचुरेशन रीजन में ऑपरेट होता है तो हम बोलते हैं कि इट्स अ टर्न ऑन कंडीशन, thereby causing an open circuit, and this cause a high potential at the collector of Q2 represented by Vc2. This increased potential, as shown in a figure above, is supplied at the base of transistor Q1, thus causing it to get short circuit by reaching a saturation region. तो जब स्विच क्लोज होता है तो वो शॉर्ट सर्किट की तरह एक्ट करेगा, और जब स्विच ओपन होगा या स्विच जब ऑफ होगा उस कंडीशन में ओपन सर्किट की तरह एक्ट करेगा. Hence, the assumption taken at the beginning is satisfied. After some duration, Q1 completely reaches the saturation region and Q2 at the cutoff region. As we are taking output at the collector of Q1, thus at saturation region Vc is minimum. So the first unstable state achieved will be 0. Now moving further, VBB come into action, due to which a current start to flow from VBB to Q2, as Q2 is in the cutoff region and behaving as an open circuit. So the current charge the capacitor C1 connected in the circuit, thus producing a voltage across C1. This high voltage is fed to the base of Q2, hence causing it to move saturation from cutoff region by starting conduction. Thus, ultimately reduce the collector voltage at Q2 and thereby providing minimum voltage. This low voltage is then fed to the base of Q1, hence now it moves to the cutoff region. Ultimately, the collector current potential at Q1 is increased rapidly. Hence, the next unstable state achieved is a high voltage, that is 1. In this way, the full operating cycle operates in order to provide a complete square wave at the output. The duration of each of the unstable state is dependent on the time constant. Let us now understand how a complementary transistor astable multivibrator works. So the second is complementary transistor astable multivibrators. An astable multivibrator can also be formed by making use of complementary pair of transistors. In this case, unlike two transistors are stable multivibrator, both the transistor either get on or off at the same time when supply is provided. So this is the circuit diagram for complementary transistor are stable multivibrator. इसमें भी हमने दो ट्रांजिस्टर का यूज किया हुआ है. As here the power is taken from some short period of the time from the supply at the time when the transistor is on, thus it consumes very less power as compared to collector couple a stable multivibrator. The figure shows the circuit diagram of a complementary transistor or stable multivibrator circuit. As we can see, Q1 is the PNP transistor and Q2 is the NPN transistor. When power is applied at the circuit, the capacitor in the circuit starts charging up to the applied potential. When the voltage across the capacitor reaches the summation of general voltage and the cutoff voltage of the transistor, the emitter base junction of NPN transistor Q2 gets forward biased. As Q2 start conduction, now the collector current start to flow through the emitter base junction of PNP transistor Q1. This means that the collector current of the transistor Q2 act as the base current of the transistor Q1 denoted by I2. Also, the collector current of Q1 denoted by I1 is less current of Q2, which can be clearly seen from the figure shown above. तो ये जो भी हम स्टडी कर रहे हैं पढ़ रहे हैं वो सारा फिगर के थ्रू हम या फिगर को स्टडी कर रहे हैं. वो डायग्राम आप पहले अच्छे से कॉपी में बना लें, उसके बाद ये देखें तो अच्छे से आप रिलेट कर पाएंगे दोनों चीज़ों को, थ्योरी प्लस डायग्राम को. Hence, when the base of Q2 is increased, then both the transistor comes to saturation region and causing it to come to on state, ultimately discharging the capacitor. When the capacitor discharges, the base current of both the transistors now gets decreased, thus causing the transistor to get off. The process repeats in order to provide continuous output in case of the unstable multivibrator circuits. Now next is the advantages of unstable multivibrator. Due to continuous oscillation between two unstable states, it is power efficient, it is design or its design is simple, and it is inexpensive. Next is the disadvantages or drawback of unstable multivibrators. The feedback provided in case of unstable multivibrator does not completely provide entire output to the input. Now next is the application of unstable multivibrators. So these are widely used in radio equipment, in timing circuits and the system that required square wave as output. तो ये कुछ एप्लीकेशंस हैं अनस्टेबल मल्टीवाइब्रेटर सर्किट की. Now the next topic is monostable multivibrator. So what is monostable multivibrator? मोनो का मतलब होता है सिंगल और वन स्टेबल का मतलब होता है हमारे पास दो स्टेट हैं 0 और 1, तो इसमें मोनो में हमारे पास एक स्टेबल स्टेट हमें मिलती है और दूसरी वाली हमारी क्वासी स्टेबल स्टेट होती है. सो दिस इज आल्सो नोन एज द वन शूट मल्टी वाइब्रेटर और वी कैन से दैट द मोनो स्टेबल मल्टी वाइब्रेटर. चलिए डेफिनेशन देख लेते हैं. सो डेफिनेशन ऑफ मोनो स्टेबल मल्टी वाइब्रेटर इज अ टाइप ऑफ मल्टी वाइब्रेटर दैट हैज सिंगल स्टेबल स्टेट. जो अभी मैंने आपको बताया. Mono means one, thus the name itself indicate one state stable and a quasi-stable state. It is also known as the one-shot multivibrator. Here, a triggering pulse is used in order to have a transition from a stable state to quasi-stable state. तो हमें triggering pulse की ज़रूरत पड़ती है या यूज होती है जब हम stable state से quasi-stable state में जाते हैं. बट अगर रिटर्न करना है मीन्स क्वासी स्टेबल स्टेट से स्टेबल स्टेट में आने के लिए ट्रिगरिंग पल्स की जरूरत नहीं पड़ती. मीन्स नो एनी ट्रिगरिंग पल्स इज प्रोवाइडेड टू हैव ट्रांजिशन फ्रॉम क्वासी टू स्टेबल स्टेट. व्हाई? बिकॉज आफ्टर अ प्री डिटरमाइंड टाइम interval the quasi state return automatically to the stable state. The figure show or by using the figure below will help you to understand the basics of monostable multivibrator. So this is the diagram. Monostable multivibrators. ये इनपुट में हम इसको ट्रिगरिंग पल्स हमें देनी पड़ रही है. क्यों यूज हो रहा है ट्रिगरिंग पल्स? जब हमें स्टेबल स्टेट से क्वासी स्टेट में जाना है, सो वी कैन यूज ट्रिगरिंग पल्स T1 and we get the output in a square wave form. Circuits and operation of monostable multivibrator. So number one, collector coupled monostable multivibrator circuits. The figure shows the circuit diagram of collector coupled monostable multivibrator. सर्किट जो है वो ट्रांजिस्टर का जो कनेक्शन है सिमिलर है जैसा हमारा स्टेबल मल्टीवाइब्रेटर का था. इसमें हम ट्रिगरिंग पल्स का यूज कर रहे हैं. ये डिफरेंस है दोनों में और इसमें हमें एक स्टेबल स्टेट मिलती है. As we can see, the circuit is composed of two transistors Q1 and Q2. The circuit is designed in order to have the operation which enables transistor Q2 in conducting state and Q1 is cut off state. When plus VCC power supply is provided to the circuit, then it forward bias the transistor Q2 through resistor R2. At the same time, VVB supply reverse bias the transistor Q1 through the resistor R5 employed in the circuits. तो ये सर्किट आप बना लो. इसी को हम सर्किट को डिटेल में समझ रहे हैं. इस सर्किट को प्रॉपर्ली आप पहले कॉपी में ड्रॉ कर लें, फिर हम नेक्स्ट वाली स्लाइड में सर्किट को समझते जा रहे हैं कि ये सर्किट कैसे काम करेगा. As we know, when a high potential is provided at the base of the transistor, then it starts reaching the saturation region. This causes the collector potential of the transistor to get reduced. Similarly, due to the negative potential applied to the base of the transistor Q1, it starts reaching the cutoff region. This causes the collector potential of the transistor Q1 is increased. As the transistor gets completely cut off, a high potential is achieved at the collector of the transistor Q1. This high potential now charges the capacitor C1, which is placed between the collector of Q1 and the base of the Q2. So the potential is then fed to the base of the transistor Q2. Thus, it forward biases the transistor Q2 due to high potential at its base. Q2 start conduction. This causes the transistor to reach saturation. So, when transistor Q2 reaches saturation completely, then Vc2 becomes very low, that is almost 0. As we are taking the output from the collector of the transistor Q2 through capacitor Cc, thus 0 is achieved at the stable state of the circuit. Now, a triggering pulse of short duration but higher magnitude is applied at the base of the transistor Q1 through a capacitor C2. Thus, high magnitude pulse forward bias the transistor and Q1 start conduction. Due to this, now Q1 shift from cutoff region to the saturation region. As Q1 reaches saturation, a low potential is achieved at collector of the transistor Q1. Since the capacitor C1 was charged initially and its charge cannot be diminished easily. Thus, the charge on the capacitor is maintained. The low collector potential of Q1 is now fed to the base of the transistor Q2. This low voltage reverse bias the diode and drives Q2 through the cutoff region, thereby providing a high voltage at the collector of the transistor Q2, which is taken at output through Cc. It is noted here that this time the achieved state will be quasi-stable. This means that the output will remain high only for a predetermined time duration determined by the time constant of the circuit. After this duration, the output will become back to its stable state. The high potential at the collector of Q2 is again fed to the Q1 and drive it to saturation region. Thus, the process repeats and again a stable state is achieved. The circuit will now again need a triggering pulse in order to have transition from stable state to quasi-stable state. So, second is a emitter coupled monostable multivibrators. So this is the circuit diagram for emitter coupled monostable multivibrators. Here also we have formed the circuit that operate with Q2 as conducting and Q1 in a non-conducting state. As Q2 is in its conducting state, the large voltage drop across RE provide a negative voltage to the base of the transistor Q1. The potentiometer employed in the circuit now forward bias the transistor Q1. Due to this, now Q1 start conducting. As forward bias drives Q1 to saturation, the collector voltage of the transistor Q1 drops. This low voltage is then fed to the base of the transistor Q2 through capacitor C in the circuit. This low voltage drive Q2 to cutoff, due to which voltage drop across RE reaches the minimum. This result causes more current to flow through the transistor. Thus, low potential at the collector of Q1 drives Q2 to cutoff. By passing time, the capacitor is charged by the current flowing through the circuit. Due to the stored charge at the capacitor, a high voltage is provided at the base of Q2. This again causes Q2 to start conduction. As Q2 conducts, the voltage drop across RE also rises, resulting causing Q1 reverse bias. The process is further repeated in similar way. In the end, we achieve Q1 is cut off and Q2 in the saturation region. Thus, the original stable state is achieved from quasi-stable. This is how a monostable multivibrator works. Now, the advantages of monostable multivibrator is these are inexpensive and the circuit design is simple. The drawback of monostable multivibrator is to provide sufficient charging and discharging time to the capacitor. The time to apply the upcoming triggering pulse must be more than the predetermined time constant. So this is the limitation. Next is the application of monostable multivibrator. It is basically used in regeneration of the distorted pulse. It is provide a sharp pulse from a distorted pulse. Also, the output of monostable multivibrator is used to trigger any other pulse generator circuits. Next topic is bistable multivibrator. A bistable multivibrator has टू स्टेबल स्टेट. नाम से ही समझ में आ रहा है, बाय मतलब दो, स्टेबल मींस स्टेबल स्टेट, तो इसमें हमारी स्टेबल स्टेट दो होती हैं. Here a separate trigger pulse is required in order to have transition from one stable state to another stable state. Here only DC coupling is provided by coupling network, and hence the energy storing element is not required. Let us have a look at the pictorial configuration of a bistable multivibrator circuit is. सर्किट में हम देख पा रहे हैं कि यहाँ पे हमें टू ट्रिगरिंग पल्स लगेंगी, एक स्टेबल स्टेट से दूसरे स्टेबल स्टेट में जाने के लिए. सो देयर इज टू ट्रिगरिंग पल्स एंड वी गेट टू स्टेबल स्टेट इन आउटपुट. सो दिस इज कॉल्ड द बाइस्टेबल मल्टीवाइब्रेटर. Now next is the advantages of bistable multivibrator. It has the ability to store previous output until no any input trigger is provided. Next, the circuit design is not complex. The drawbacks of bistable multivibrator is every time in order to have transition from one stable state to another, triggering pulse is required. Number next, it is somewhat कॉस्टली देन अनस्टेबल और मोनोस्टेबल मल्टीवाइब्रेटर. जब इसमें हमें दो ट्रिगरिंग पल्स देनी पड़ती हैं तो ये हमारा सर्किट जो है वो थोड़ा सा कॉस्टली हो जाता है. Now the application of bistable multivibrators. So these are widely used in the circuits of latches and counters. It is also used in frequency divider circuits and in storage devices. So these are some application of bistable multivibrator circuits. So these are the references of this presentation. And thank you for watching this video.